Ladies and gentlemen, good afternoon. This is Bruce, G4ABX, and welcome to my YouTube channel. This afternoon we're going to continue with the build of the Kanga Products N-Fed half-wave, or N-Fed antenna tuner, this little fella. I decided to have a go at this because it's probably going to be easier, given the number of different situations I find myself in running portable operations. It's probably going to be easier to have a small ATU than multiple bits of wire, baluns, etc, etc. So I've decided that we'll have a go with this antenna tuner. Just before I do that, this is where I got the tuner from, Kanga Products. Recently taken over because Kanga had been closed for quite some time, and delighted to see it back. When I was a lad many years ago, Kanga was a well-known supplier of well, kits and things for amateur radio in the UK, and I'm delighted to see that that they're back. So this is the first product that I will have tried in recent times, so I'm sure it will be just as satisfying to build and to use as all of their other products have been in the past. So my very best wishes to the new proprietor and the team at Kanga Products. Okay, so let's move on. I probably don't need the case for now. I'll just take the box off there. I probably am going to use this. For those of us that, shall we say, are not quite as young as we used to be, this is an amazing piece of kit for building any kind of electronics. This was I don't know, an Amazon purchase, I think. This is a copy rather than being the original. The originals now are more than £100. I think this was about £20, so well worth it. Really useful piece of kit. The other bit of kit that I've got, another bit of plastic if you're building anything. This is a great piece of kit for bending wired components to the correct pitch to fit in printed circuit boards, and I shall be using this too, along with a pair of inexpensive cutters and my fingers, and we'll see how we go after that. So then, let's start opening up some of this stuff, and let's start with the printed circuit board and see what we've got here. So the PCB, nicely made, FR4, so fiberglass construction, very tough, strong. And let's have a quick look at the instructions. Pretty unusual for a radio amateur to look at instructions for anything. You normally just crack on and stop when you've not got it to work and start again. So let's have a look and see what it is that Kanga suggests we do first, and I may end up doing that first. Right, so here we go. Toroids. Toroids. You can't get away from winding toroids these days. So let's have a look at what we got. So we got a T50-6 core, and half mil wire. And apparently we need about 25 turns onto the core. So to give us a 49:1 transformation, we need an impedance ratio of 7:1 in terms of turns. So if we're going to have 25 to fill the toroid, let me see if I can get that fellow out. Let's open up this little bag of all the bits and pieces that we need. See what we got here. What's that? A bit of connecting wire. So there's the toroid. Don't need the knob at the moment, but probably will need the enamelled wire. I'm guessing this is polycon wire. By that I mean it's wire that will, the enamel, as it were, the coating, will happily evaporate once you apply hot solder to it. But you always have to tin this kind of lead. The other thing I suggest you do when you're winding a toroid, I just get a pair of pliers out of here. sorry for the noise. The other thing I suggest you do is that if you're going to wind toroids, then one of the things that is quite useful is actually to stretch the cable, stretch the wire a little bit to get all the kinks out of it. So you won't be able to see all the length of that, but just grab hold of it. I have a little vise here on the end of the bench which you can't see, but I'm going to use that just to stretch the wire so that it's easier to wind. There we go, splendid. Right, so now we have the wire, and I've got to get 25 turns. What's it telling me to do here? 3 turns, then make a tap. Oh, okay. So we're not winding multiple windings at the same time. We are simply going to create a tap with this. So let's have a look at how we're doing with this. Now remember, with a core, each time you pass through is 1 turn. So I don't need too much at this end. So let's have a look. This is going to be a bit boring, so I will speed this up in what is technically called post-production. Me trying to make sense of it all is really what happens. Just pull that a bit tighter. Right, so there's our toroid wound. So with 25, I'm just going to spread it out now a little bit around the toroid. It's not absolutely necessary, but it's nice to be neat if you can. Okay, so there we have it. So we have 3 terminals to our toroid. We have the tap, which is at 3 turns. We have the top, and we have the ground. So not terribly complicated to wind. It just takes a little while, and be patient. When you've wound a bunch of these for a receiver, low pass filter or something like that, it's a lot more effort than just winding one. That's one of the nice things about this particular design. You've only got to wind 1 toroid, so that'll all be good. Right then, so what's next? Time to crop the unneeded wire off it. So there's our toroid completed. Right, I'll just put that to one side over there. Oh, bit of publicity for Kanga while I'm doing it. I really appreciate small companies and the way they really contribute to the amateur radio experience. It's not just large companies. The small ones, we need to encourage them. So, I encourage you to do whatever you can. If you're going to buy something, see if you can buy it from an independent supplier. Right then, let's carry on and have a look at this. So now we need to tin this contraption. Basically that's soldering the wires up. So let's have a look at how we do that. I get some solder. I need me things for that. If you're soldering, this is quite a useful thing. A replaceable copper Brillo pad, I suppose you could call it. You buy these replacements. I buy them from Amazon. 2 or 3 of these. Well, I never consume more than one every 2 or 3 years. So, half a dozen of these will do you most of your constructing life. But they are absolutely brilliant for cleaning soldering iron tips, because you kind of need, with soldering, you really need everything to be clean. So then, let's have a look at where this is going to go on the board. Right, okay, so there's the toroid, the top, the ground and the tap. So this is the top, that's the ground, and that's the tap. Well, that's amazing, they come out in the right place. Brilliant. Once you get the solder on here, it will actually melt the enamel. It doesn't smell very nice, so I suggest you keep your nose out the way as your soldering iron. As you can see, there's quite a few fumes. So can you see the way that the solder is actually melting this solderable enamel, which is great. Now this is a little more difficult. The technique is to start off the wire near the end, and then as you get it hot, it will continue to melt as you progress up to where you need essentially the tinning to cease. So I'm just going to continue tinning this a bit further. Otherwise you'll end up pushing something through the board that is untinned, and the net result of that is it won't work. Right, wow, that's actually got quite warm. Not surprising really, it is copper wire and I'm applying 400 degrees of soldering iron to it, so it's bound to have some sort of thermal effect, shall we say, copper being a good conductor of heat. Try and crop things reasonably flush without necessarily cutting the joint, because if you actually cut through the soldered joint, you can damage it. So you just want to crop the wire out the way. Okay, and a quick look at the top will tell you whether the solder has flowed through everywhere. Yeah, I think it has. But I'm just going to retouch up that joint there. There we go. Right. Chop these out, not lose any of these bits. Right, so there's the shaft extender, and essentially what will happen is that will be the thing that we screw into the tuning knob. And I imagine we simply screw those two things together very gently, because these polyvaricon capacitors, which are these are not very robust. So we want to be careful we don't break anything, because you could quite easily, if you apply too much torque on a screwdriver, quite easily break something. I'd just get a screwdriver. When we get to the tap, I'm going to bend the tap up and I'm going to solder the tap just at the surface there. So I should probably do that first, so that we know we've got good connection without it having gone through the board. Right, back to the helping hands. This is the trickiest bit. It's always difficult with these projects. So there we go. So that's what I've done. I've actually soldered it to the top of the board rather than pushing the tap through the board, because having twisted the wires together, their diameter is greater than the hole in the printed circuit board. But that's not a problem, and with the others we can simply solder those in place. Okay, so far we have got the switch fitted, we've got capacitor fitted, not soldered it yet, notice. The LED is pushed through the front, again not soldered yet. And now we need to finish that construction with the connectors. Solder the tab on the board, and I'll just trim off the excess here. So other than connecting this up in the box now to the BNC, it's finished, which didn't take terribly long. I should probably end up running this at higher speed, shall we say, so you don't have to sit through the whole thing. But we can adjust the inductance slightly by moving the turns closer together or further apart if we can't get a match. Sensitivity of the LED, this fella here, is what will indicate the SWR, and what essentially you do, having connected up your antenna and your rig, is you tune for minimum burn on the LED, so minimum brightness of the LED in the tune mode. And once you've got that sorted, switch it to operate. If you don't switch it between tune and operate, what you do is you put one of these resistors in series with your output, which A, isn't very good for efficiency, and B, if you're running 10 watts, is going to heat this resistor up pretty quickly. So you don't want to do that. So tune and operate, really simple. Great piece of kit. I'm really impressed with that as an afternoon's project. Excellent. So this will all fit nicely inside the case. There'll be a BNC socket here, I haven't put that in yet, I'll do that in a moment. And of course we have a knob that we can fit on there, but I bet my screwdriver won't get down there. No, it won't. So I need to find a smaller screwdriver in order to get down to that. Okay, smaller screwdriver found. So adjust the control all one way to there. And now we can just tighten the knob up, and that will give us nice control. Again, we don't need to be fierce with this. The dip will probably happen fairly quickly, but we'll test this. We'll test this later. Okay, I'm just going to get on and finish this off with the BNC socket, and we have 5 screws for fixing the thing together. They're guaranteed we're going to lose one, which is great. So let's put the BNC socket in. BNC socket has both a serrated washer, fixing washer, and of course a solder tag. So that fellow in first. I suggest we bend the solder tag out a bit so we can get at it. Serrated washer, and then the fixing washer. And there we have it. One QRP, 10 watts maximum, end fed antenna tuner. So now all we need to do is to see how well it works. So that'll be a bit later. 73s for now.
We're sorry, the number you have dialed is not in service at this time.